Hi, fourth grade. Today, we're doing lesson 4 in module 6. Our objective for lesson 4 is to use meters to model the decomposition of one whole into hundredths. Represent and count hundredths. So today we're going to take what we know about dividing a whole into tenths. We're going to expand it and divide a whole into 100ths. Let's get started on page 23 with today's application problem. Everybody take a look at page 23, please, in your blue Learn books. I'm going to put it up on my screen right now. Allie is knitting a scarf that will be 2 meters long. So far, she has knitted 1 2/10 meters. How many more meters does Allie need to knit to complete the scarf? Write the answer as a fraction and as a decimal. So let's stop and pull out the important information here. Important numbers, okay? We know that the scarf will be 2 meters long. Okay, it will be, tells us that it is not yet. The scarf is still growing, getting bigger, right? So we are going to need to find maybe a missing part of an amount, is what those words tell me. So far, she has knitted 1 2/10 meters. That's how far she's gotten, and her goal is to knit a scarf that is 2 meters long. Underline your question. How many more meters does Allie need to knit to complete the scarf? We need to write the answer as a fraction and as a decimal. There are 2 ways you can represent this problem. Okay, if remember we're using cubes, but we're also going to use RDW to read, draw, and write as we find the solution. Okay, so we've read and we've used cubes, right? Using cubes as part of the R. Now we are going to draw. There's a couple different things you can draw to help you solve this problem. We could draw a number line, could also draw a tape diagram. Okay, they're similar in some ways and they can represent the same information. We're going to start with a number line. Draw yourself a number line, make it nice and long. Try to make it look just like mine. We have 0 at the end of our number line, at the beginning of our number line, and we have 2 at the end of our number line, and our unit in this problem is meters, which is represented with an M, okay? So we have 0 meters, 2 meters, and in between we have 1 meter. We want to start by representing what Allie has already, okay? So far, she has knitted 1 2/10 meters of scarf. We want to show that on the number line, but we need to divide this meter into tenths to show that value. So I'm going to divide it in half, and then I'm going to divide each half into fifths. She has knitted 1 2/10 meters. So from 0, which is where she starts, right, when she has no scarf, we're going to travel with a line, try to make yours look just like mine, to 1 2/10 meters. And we're gonna show that value right here, 1 2/10. Let's mark that point and label it 1 2/10 meters. what is the distance we still need to cover to get to 2 meters? Which is our goal, right? The scarf will be 2 meters long. Right now it is 1 2/10 of a meter. How far am I traveling when I do this to grow the size of my scarf from 1 2/10 of a meter to 2 meters? Another way I could ask that question is, what is the difference between between 2 meters and 1 2/10 of a meter? Okay, that would be a subtraction problem. And the answer is 8/10. And we can see that here in a number sentence. 1 2/10 plus 8/10 equals 2. 1 2/10 plus 8/10 equals 2. Okay, 202. There is another way that we can represent this information using meters and centimeters. Okay, what we're going to talk about today is when we're talking about tenths, we can use the metric system to recognize that. Okay, 1 meter is the same as 100 centimeters. Copy this number line down now. I'm going to give everybody some time since I already have it written down. What's important to recognize is that 5/10 of a meter is equivalent to 50 centimeters. 8/10 of a meter is equivalent to 80 centimeters. 1/10 of a meter equals 10 centimeters. And 8/10 of a meter equals 80 centimeters. We know from our work in the first part of the problem that Allie needs to knit 8/10 of a meter more. And if we want to say 8/10 of a meter in centimeters, we know that we can say 80 centimeters because 1/10 of a meter equals 10 centimeters. 8/10 of a meter equals 80 centimeters. Allie needs to knit 80 more centimeters. Okay, the most important thing for us to understand today, and that we're going to focus on understanding through fractions and decimals, is that 1 meter equals 100 centimeters. Have your paper and your pencil ready? You should be writing with me. 1 meter equals 100 centimeters. We can show how a meter is divided into equal parts by drawing a tape diagram. Underneath what we just drew, or what we just wrote, let's draw a tape diagram. Divide your tape diagram into 10 equal parts. You can pause the video if you need to. Separate it in half, and then each half into 5 parts. Each of these 10 parts is worth 1/10 of a meter. Right? Our whole is 1 meter. And our 1 meter, is divided into 10 equal parts. Each part is 1/10 of a meter. If 1 meter is 100 centimeters, 1/10 of a meter equals 10 centimeters. Each of these equal parts is worth 10 centimeters, and if you count by 10, you will get to 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 centimeters. 1/10 of a meter equals 10 centimeters. 1/100th of a meter equals 1 centimeter. There are 100 centimeters in a meter. So when we divide a meter into 100 equal parts, we have 100 centimeters. 1 centimeter equals 1/100th of a meter. So in this 1/10 of a meter, you have 10 centimeters. We can also show these values as decimals. We've been talking about decimals since we started remote learning, so let's show them that way. 1 centimeter equals 1/100th of a meter, and we write that this way. 1/100th of a meter. These are all equivalent values. Now, 1/10 of a meter is written like this, 0.1 meters. Take 30 seconds and make sure that your paper looks like mine. This helps us understand how centimeters and meters are related, but also how we can separate a whole into tenths and 100ths. Let's draw a tape diagram again to show 1 meter, just like we did before. On a fresh piece of paper, use all the paper, draw a nice big tape diagram. Divide it into 10 equal parts. All right, so down the middle, and then each half into into 5. One meter, label your hole. One meter. Let's say that we want to show 25 100ths of a meter. Let's write that as a fraction. Your paper should look like mine. You can also write it as a decimal. How can we show 25 100ths of a meter with this tape diagram? We know that our meter is separated into tenths, 10 equal parts. And we know if we look back to the problem that we just completed, the work we just did here, 1/10 of a meter is equal to 10 centimeters. So if we have 2/10 of a meter here, we know that each tenth of a meter contains 10 centimeters. So 2/10 of a meter together makes 20 centimeters. Each 1/10 of a meter contains 10 centimeters. And it is our job to show 25 100ths of a meter. 10 centimeters is equal to 10 100ths of a meter. Each 1/10 of a meter is the same as 10 100ths of a meter. 1/10 and 10 100ths are equivalent fractions. So if we want to show 25 100ths of a meter, we know we can show 20 100ths by shading how many? 2 of our equal portions. Let's shade them now to show 20 100ths of a meter. So we have 10 100ths and 10 100ths. We need to show 5 more 100ths to get to 25 100ths. And if each section is worth 10, it's going to be hard to see my lines, but we can separate this into 10 100ths. And if we need 5 more 100ths to get to 25, we will just shade in 5 100ths, or 1/2 of 10 100ths, right? Because this would be 10 100ths. Shading half of that would give us our 5 100ths. So again, we have 25 100ths of a meter, 25 100ths of a meter, shown 3 different ways: fraction, decimal, tape diagram. And we know that if our whole is a meter, then 25 100ths of a meter is equal to 25 centimeters, because in each meter there are 100 centimeters. 1 meter is equal to 100 centimeters. Okay, let's take a look at the problem set. Page 25, we're going to go through number 1 together. I'm going to have you do number 3 by yourselves, but we're going to do a sample so that you can see exactly what needs to be done to complete your exit ticket, okay? So let's start on page 26. Turn to page 26. Shade in the amount shown, then write the equivalent decimal. 8/10 of a meter is shown in fraction form. We have a tape diagram here. Shade in the amount shown. You're going to shade 8/10 of your tape diagram. Shade 8 is 4. 8/10 of a meter. 8 out of 10 equal spaces. Write the equivalent decimal. 8/10 in decimal form, we know, is 0.8. 8/10, it's said the same way. 7 100ths of a meter is the next section. This is going to look very different. Do not shade in 7 the way we just shaded in 8. 7 100ths is very different than 7/10. Remember, this is 8/10. This is 7 100ths. If we're shading in 7 100ths, remember that inside each 10th is 10 100ths. So if this tenth is separated into 10. You're going to shade just 7. So it might be hard to do neatly because it's such a small space, but we need to try to shade in 7 out of 10 in that small section there, because 7/100ths is just 7 centimeters out of 1 meter. And one of these equal spaces represents 10/100ths or 10 centimeters. So 7/100ths has to be less than that. And 19/100ths of a meter, if each of these is 10/100ths, 19/100ths will be just less than 20/100ths, which is 2 of these equal spaces put together. Remember, each one is 10/100ths. So if I wanted to draw a line for 19/100ths, I would make it just short of that 20/100ths and shade just less than 20/100ths, exactly 19/100ths. Let's not forget to write these as decimals. I'm going to go back to part B. 0.07 is 7/100ths. Just 7 centimeters, 7 1/100ths out of 1 whole. And 19/100ths is like 1/10, and 9/100ths is written as 0.19. Number 5 on the problem set is going to show us this is the second part of your exit ticket. You'll see looks similar to that. Draw a number bond, pulling out tenths from the hundredths, as in problem 3. Write the total as the equivalent decimal. That can look like this. 19/100ths, you can write it as a fraction, or I'm choosing to write it as a decimal. Can be separated out into 1/10 and 9/100ths. One-tenth and 9/100ths together is 19/100ths of a meter. Don't forget your units. Let's look at letter B, 28/100ths. Let's separate, this time I'm choosing to write as a fraction, 28/100ths separated out into tenths is 2/10 and 8/100ths. Right now, I'm going to show you how to do C and D on my paper, but before I do that, I want you to pause this video and try to do them yourselves. Then unpause me, and we'll see if you got it right. Let's take a look. 77/100ths. This time I'm going to do everything in all decimals. Remember that decimals and fractions are representing the same values. 77/100ths written as a decimal, 0.77. And if I separate out my tenths, I have 7/10, and my 100ths, I have 0.07. 7/10 and 7/100ths together makes 77/100ths. And 94/100ths is done the same way. 94/100ths can be separated into 9/10 and 4/100ths. Number 4 and number 5 that we just did give you all the information you need to complete your exit ticket today. Okay, 4th grade, see you tomorrow. Don't forget to like and subscribe.